The dermis is the gelatinous body stocking. It's full of water, and it lies deep to the epidermis, which forms the hard candy shell with its many layers of dead cells. In the picture that you see here, the dermis is all of the pink. This is all of the dermis right here, all the pink, no purple, no purple. Remember, epithelial tissue that lines an open space, that usually takes up that purple color with the H&E stain that we commonly use. The dermis here, though, is full of collagen bundles, and they like to take up this very pink stain. These collagen bundles, they bind water, making your dermis a huge reservoir for fluid in your body. And this is why skin health can be maintained by drinking lots of water. If you want to continue to look young and healthy, I guess if you are still young and healthy, I'm not. But if you want to continue that, lay off the coffee and drink water. Okay, so the water contact of the dermis, it creates this really strange effect called an artifact when it's dried and made into histological slides like this. The water of the dermis, it evaporates away. And just like a leather belt that hasn't been oiled, the dermal tissue on the glass slide, it starts to crack and blister. And sometimes it distorts in shape as all of that water that was bound to the collagen starts to evaporate off the slide. It's just part of the process of making and staining a picture like this. So the collagen bundles of the dermis, what they do is they tear away from each other as the water evaporates off. And this leaves all these little cracks that you see that look like open white spaces. So those cracks, they're characteristic of dense irregular tissue that's found in the bulk of the dermis. But I want you to keep this in mind as we view histological slides in this class. You have to remember, this is not what your skin looks like on your body. Tissues are dried and manipulated and stained before you get to see them in a picture like this. And it's important to remember that water evaporates and it can leave these artifacts or open spaces on the dermis. Whereas the epidermis had all those strata, the dermis has its own two layers. The papillary layer is a very, very thin of areolar tissue, a connective tissue, loose connective tissue. And the papillary layer is just deep to the border of the epidermis and the dermis. And I want to remind you that this here is the border, right? The epidermis is all the purple, the dermis is all of the pink. So papilla means nipple, and this dermal sublayer is so named for these projections that are called dermal papilla. They're basically nipple-like or finger-like projections that project into the epidermis. In the epidermis lecture, we found that this is to increase the ability of the epidermis to attach to the dermis, but that wavy layer, it also increases the diffusion of oxygen and glucose from the blood vessels in the dermis to the avascular epidermis. There are also free nerve endings in this superficial layer of the dermis, and these free nerve endings are just that. They're the dead end of a nerve. Actually, no, they're not the end. They're the dead start of a nerve. So they're for incoming information, not outgoing. They can detect things like temperature and pain. Their placement in the papillary layer allows them to assess the temperature of epidermal cells in an effort to determine the outside temperature. And we're going to see that free nerve endings, there's so many in many other organs. Phagocytes roam around the papillary layer of the dermis. The term phago or phagocyte means eating cell. And these are actually they are white blood cells, And what they do is they exit the blood and they enter a tissue and they roam around at here, the papillary layer of the dermis. And what they do is they engulf anything that they don't recognize, right? And they do that by endocytosis. Then they take what they found to a lymph node where it can be further assessed, and they're kind of like, I found this. And the white blood cells in the lymph node, they decide whether mobilization of the immune system is required. We'll also see macrophages, which are just cells that do a lot of eating, right? There's phagocytes that eat, but macrophages eat a lot. But macrophages, or these phagocytes in the dermis, they just roam the border of the epidermis and the dermis to catch any invader before it can get any deeper into the dermis and, possibly contact a blood vessel, which is what you absolutely do not want. The word reticular means network or web, and we've seen this word before. It's used a lot as an adjective in many areas of the body. The reticular layer of the dermis is like the deepest 80% of the dermis. So think about this for a minute of how shallow that papillary layer is if pretty much all of this is that reticular layer of the dermis. In many areas of the body, the reticular layer contacts the hypodermis at its deepest boundary. And this layer results in that pinkish, torn tissue-looking appearance of the dense, regular connective tissue. It's in the dermis that we're also going to see specific sensory receptors, not free nerve endings, but very specific pressure sensors and sensation sensors, as well as arteries, veins, lymphatic vessels. If you're unsure where a certain structure is in skin, you can probably guess dermis, and it's correct. Over here on the right is an electron microscope picture of the dermis. The dermis, again, even with an electron microscope, it is not that color. It's not green. Those are the colors that the person who applied the final touches to the electron microscope picture, just like you would stain a tissue, there was someone who applied that green and pukish color to kind of tell the tissues apart. Although the dermis is covered by the epidermis, changes associated with aging in the dermis can be seen on the surface of the skin. Because the epidermis, if you think about it, it's just like a dermis covering, like a stocking, right? It dips and rises with the valleys and the hills of the dermis. So wrinkles, they occur as collagen breaks down and pretty much disappears from the reticular layer of the dermis. Why does collagen break down, you ask? Well, I answered this. Water. As you age, you naturally become more dehydrated more easily. And your dermis, being the big water reservoir that it is, it suffers the most damage from that natural dehydration that just comes with aging. This is different than stretch marks, though, which do not come from water loss. Stretch marks occur from torn collagen bundles. Have you ever torn the skin off a chicken? Not like a live one, but like a piece of chicken that's cooked. And you can see it kind of tear off the muscle beneath it. Those are the collagen fibers that you are ripping apart on that chicken. Therefore, stretch marks happen with tugging and pulling of the skin in the same way. This can happen because of weight gain, but it can also be the product of a myriad of prosthetic devices that are poorly fitting. I knew somebody with a prosthetic leg that suctioned to the hip, and he had stretch marks all over the hip skin from the prosthesis's downward force. Can you make stretch marks go away, you ask? I don't know, you tell me. There's no miracle cure, but treating your skin right from the start it is a start. You have to remember that the flow of things in your skin is from deep to superficial. Cells and nutrients move from deep. Hold on, let me get the highlighter. Cells and nutrients move from deep to superficial. And further, actually. Therefore, putting on a cream is not a great way to help your dermis, since the cream would have to penetrate all the way through your epidermal layers and into the dermis to make any difference. Eating right, taking biotin and other vitamins can help. You have to provide the dermis with what it needs from the inside, not from the outside.